So in this lesson, we're talking about proving parallel or proving lines are parallel. We're going to be working on proofs just because it's that important. The building block, we're going to be using it in lots of different lessons. We have to get better with proofs. So when you're able to write your proof, we're going to be good to go. So one of the skills that you need and that we practiced a little bit in previous lessons is once you have the given, then you're moving on to the picture and you're trying to squeeze as much information as you can. So it could be from the given, trying to get more information from the given, or it could be trying to squeeze more information from the picture. So we're going to practice squeezing more information from the given statement. So figuring out, what does that statement mean? Sometimes it's taking the statement and changing it from words to math, like an equation. Sometimes it's just kind of rewriting it, almost just using a definition. So here's one example. We've got angle 3 and angle 4 are right angles. That's a given. But what else can we squeeze out of that? What other information do we know because of that? So we know they're going to be congruent to each other because we know all right angles are 90 degrees, so they're all equal, which means they're all congruent. All right angles are congruent. We could also say that the measures are equal to each other. And if we wanted to go a little bit more specific, we could also say that they equal 90 degrees. That would work in there too. All right angles are 90, so all right angles are congruent, which means they're all equal to each other and they all equal 90. It's a lot of little information that can be squeezed out of just being right angles. So here we've got angle 5 is a right angle. Everything that we know about that. It's a right angle, means it equals 90, because right angles always equal 90. So we kind of hinted at that in the last example as well. So if you've got two vertical angles, angle 6 and angle 7 are vertical angles. There's more information from that. Since they're vertical angles, they're congruent, because all vertical angles are congruent. They're always congruent. And then since they're congruent to each other, that means their measures are equal. The measure of angle 6 is equal to the measure of angle 7. So now we're told 8 and 9 form a linear pair, which means they're supplementary, because linear pairs always add to 180. They're supplementary, which also means you can write it out as the equation. They add to 180. That's the definition of supplementary. So when you've got parallel lines with a transversal, there's a lot of information. You've got alternate interior angles are congruent, corresponding angles are congruent, and supplementary, same side interior angles are supplementary. And their reasons: alternate interior angle theorem, corresponding angle theorem, or same side interior angle theorem. You pick and choose whichever of those you need for the proof, depending on which angles you're trying to tie together. But you do need to remember how to identify each of these. That's the important part. So this is a little bit different, a little bit new. If you know that alternate interior angles are congruent, you can actually use that to say that the lines are parallel. That's called the converse of the alternate interior angle theorem. So we're using it backwards. That's why it's the converse. The lines are parallel, the angles are congruent, and if the angles are congruent, the lines are parallel. It works both ways. It's like a two-way statement. But this way is called the converse, to show the lines are parallel. So the next one, if we have alternate interior angles, well, corresponding angles is the next one. If you have corresponding angles are congruent, that also tells us the lines are parallel by the converse of the corresponding angle theory. So if you know the angles are congruent, you can say the lines are parallel by using the converse of whatever type of angle they are. Then the third type of angle in parallel lines with transversal is the same side interior. If you know that they're supplementary, then you know the lines are parallel by the converse of same side interior. So when you're doing a proof, every proof always starts with the given. No matter what they give, that's the first thing you're going to write. So M is parallel to P. And we're trying to tie angle 2 and angle 8 together to show that they are congruent. So we want to pick an angle that we know 2 relates to, maybe congruent, and another angle that we know 8 relates to, so that we can have them be congruent to each other. So with everything that we just reviewed real quick, we know there's a ton of ways that we can go about this. We could use angle 6. We could use angle 5. We can use almost anything up there. But we're going to take angle 4 in this case and tie them both to angle 4. So we know that angle 2 and angle 4 are congruent because they are vertical angles. And then we also want to tie angle 8 to angle 4. And we know that angle 8 and angle 4 are also congruent because they are corresponding angles. And then any proof where you use the same angle like that, angle 4 and angle 4, with congruent statements, you can link 2 and 8 together, the other sides, with the transitive property. Get rid of the middleman. They're linked together with 4, so just skip over the 4. It's transitive property. Flow proofs work the same way. They use the same logic, you just have to draw them differently. So angle 4 and angle 7 are supplementary. We're going to start with that. Angle 4 and angle 7 are supplementary because it's given. And from the picture, we know that 5 and 7 are congruent. Vertical angle theorem. That's what VAT is short for in this case. So we can put those together. We can substitute out the 7 for the 5. So now we've got angles 4 and 5 are supplementary. And we know that they're same side, so that means the lines are parallel by the converse of the same side interior angle postulate. So for this proof, we are going to start with the givens. So G is parallel to H, and angle 3 is congruent to angle 13. Try that again. They're both given. You can squeeze them both in one line. Sometimes you can do 2. So angle 3 is congruent to angle 13. But we also know that G and H are parallel. So since we've got parallel lines, that means we have all those angle relationships like alternate interior, same side interior, corresponding, whatever we want. So in this case, we're going to take angle 3 to angle 13 to angle 5. Now, we know we wanted to use angle 13 because that was one that was in our given. And we're going to go and we're going to take it and say it's congruent to angle 5 because they are corresponding across those parallel lines there. So they are corresponding. But then we also know that we can tie 3 and 5 together here in just a minute. So we can tie 3 to 5 because, well, not quite yet. We can tie 3 to 5 because we used 13. Kind of the middleman here. So we can write the transitive property. When you get rid of that middleman, 3 to 13, 13 to 5, we can go straight 3 to 5. That's the transitive property. But now that we have said 3 and 5 are congruent, angle 3 and angle 5 are alternate interior angles for lines M and P. So since 3 and 5 are now congruent, now we can say that lines M and P are parallel by the converse of the alternate interior angle theorem.